Number 5 says, an ideal diameter d in feet of a ship's propeller is given by the formula d is equal to c times h to the 1/5 r to the negative 3/5. Here h is the horsepower of the engine driving the propeller, r is the maximum number of revolutions per minute of the propeller, and c is a constant. In both parts, give your answer in terms of a percentage. So for part A, it says, if the horsepower is increased by 20% while the number of revolutions per minute remains the same, how is the propeller diameter affected? So even though we have two variables with two different exponents here, we can still use the homogeneity property because they're really only looking at one at a time, and they're making the other one constant. So they're increasing the horsepower, or H, by 20%. So I can't just use the 20% directly, I need to write it as 1.20. And if I raise that to its power of 1/5, then I'm going to get 1.0371, which, if I convert that back to a percentage, that means that this is increased by 3.71%. So again, you want to subtract 1 and move the decimal place over 2 to convert back from the growth factor to the percentage. For part B, it says, if the horsepower remains the same while the number of revolutions per minute is increased by 20%, how is the propeller diameter affected? So this time they're keeping H constant and you're just looking at the R. So for this one you're only concerned with the R to the negative 3/5. So I want to take that 20% and write it as 1.20 and raise it to the negative 3/5, which is going to get you 0.8964. And then I want to take that and actually subtract it from 1, because this is going to be, you're taking 0.89 as the decay factor. So to get the percentage, you want to take 1 minus 0.8964, and you're going to get 0.1036. So that will be 10.36%, or you could say a decrease by 10.36%. And that would be your answer.